Number 24. Acetylene gas, which is C2H2, undergoes a combustion to produce carbon dioxide and water vapor. Okay, and so that sounds like a chemical equation. Let's make sure that we have a balanced chemical equation. We are doing gas stoichiometry, so we will need a balanced chemical equation. So let's do that. Now, combustion means with O2, and we already know that this is a hydrocarbon, so the products will be carbon dioxide and water vapor, but we were told anyway, so that's nice. So C2H2 plus O2 reacts to form carbon dioxide and water. All right. So let's balance this up. So we got 2 carbons over here. Gonna need 2 carbons over here. Let's see. 2 right there. So we're gonna have an odd number of oxygens over here. So I'm gonna put a 2 in front of this no matter what. So it's gonna be 2. It's gonna be 4 hydrogens. So I put a 2 over here, that'll be 4 hydrogens over here. And that will be have carbons. Okay. So 2, 2. So in terms of carbons, I have 2 on this side, 2 on that side. Hydrogens over here. Oh no, I gotta double that up. That's right. 2 here. 7 here. 4. 4. Let's do that. Right? Alright, so 4 carbons, 4 carbons, 4 hydrogens, 4 hydrogens. Now in terms of oxygens, that should be good because making sure that there's an even number coefficient on this water is going to ensure that there's an even number of oxygens. So no matter what, I'll be able to fill in what I need with this coefficient for the O2. So I have 8 oxygens there, 2 more there, so a total of 10. I need a coefficient of 5 in front of my O2. So 2 to 5 to 4 to 2. Okay. So if 75 liters of carbon dioxide are produced, right? Carbon dioxide right here. 75 liters. How many liters of C2H2 are required? So 75 liters CO2 and convert out of liters of CO2, then go into liters of C2H2. Carbon dioxide will cancel. I'll be in acetylene, which is what I want. Now, what is my ratio? 2 to 4. Get the calculator going. 75 times 2 divided by 4. We end up with 37.5. And I'm okay with the 3 significant figures. 37.5 liters of acetylene. B, what volume of water vapor is produced? So again, let's start with this 75.0 liters of carbon dioxide. Convert out of liters of carbon dioxide into liters of the water vapor so that my carbon dioxide will cancel. What's my volume of, what's my ratio of water to CO2? Water to CO2. Almost got messed up there. Again, it's a 2 to 4. So without even busting out my calculator again, I know it's 37.5 liters. Lastly, what volume of O2 is required? What volume? Let's see. Oh, okay. So we're still starting with 75 liters of CO2. Again, I'm always starting with the 75 liters of CO2 because that's what the question gave me to start with. Want to convert out of liters of CO2 and go into liters of O2, right? Because we said that there has to be sufficient O2 to react with this volume of CO2. So how much, right? How much of this is involved in the reaction? So liters of CO2, again, that is a 4. Liters of O2, that's a 5. So it's a 5 to 4 ratio. Liters of carbon dioxide cancel out. So my answer will be in terms of liters of O2. Time to calculate. 75 times 5 divided by 4. Let's see. I'm going to want 3 significant figures still. So that 5 is going to tell that 7 to become an 8. So 93.8 liters of O2.